Lesson 712, the unit circle. So a common aid when we're looking at trigonometric ratios in mathematics is something called the unit circle. It has some preset um, degrees and radian rotations on it, and it has certain coordinates of points on it that are relatable to our two special triangles we looked at. Those are the 45, 45, 90 and the 30, 60, 90. And this is something as we move forward, and we definitely, when we get to pre-calc, is something that we do memorize and that we use to help us think logically through other steps in mathematics. So just a little review here is that making sure we understand on a unit circle, radius is 1. That's nothing new. We talked about that. We have these trig ratios. The most important three are that the x value is the cosine, the y value is the sine, and that the ratio of those is our tangent. And then from there we can find we have three other reciprocal ones, which is just those values flipped. So what we're going to do here is ultimately we want to fill in all of these spots. And the first thing I want us to do is this, and then we'll do this with you, is I want to start with that this right here is 0. If this is our angle, this is 0 degrees. And right below it, will you write down 360 degrees? So that is either no rotations or one complete rotation. And then some of our other important measurements to look at, that this measurement is 90 degrees. As far as radians, that's pi over 2. We talked about converting that. This measurement here, we go another quarter. This is 180 degrees, or pi radians. This is 270 degrees, or 3 pi over 2 radians. And then obviously we already started 360 degrees or 2 pi radians. So 0 degrees or 0 radians. So these are kind of some of our marks that we started talking about. And this is obviously quadrant 1, quadrant 2, quadrant 3, and then we have quadrant 4. And then these other pieces here, the parentheses, these are points. And then the two values that are left blank to be filled in are coordinates of those points. So let's start off with this. If we have a 0 degree rotation or a 360 degree rotation, this coordinate would be 1 unit because it's the radius, comma 0. The y value is 0. If we have this point here, we know that this is 0 degrees for the x value or cosine and 1 degree for the y value. We know it's -1 for the x value, 0 for the y value, and this one is 0, -1. Okay? Now, what we will also want to talk about is some of these other spots. Hopefully you see a lot of symmetry here. The first thing we're going to do is we're going to talk about these spots right here. These look like halfway marks in between each of our quadrant. And so if we think about half of this, we can think about that being a 45 degree rotation. So would you write that in there? So that's 45 degrees. The other thing I want you to think about is that that's like a 45 degree reference angle here. So a 45 degree reference angle off of 180, that would make this rotation right here 135 degrees. We'll fill these in. We're going to leave the radians for later. You can fill those in at the end. You can convert those or whatnot. We'll talk about that at another point. And then right here is halfway in between 180 and 270. You can either add 45 to 180 or subtract 45 from 270 here. 225, and then this mark, same logic. This mark is 315 degrees. Okay, now as far as these points, what are the coordinates? We're going to go back and we're going to fill those in. What I want you to do is go to this next side here. This next side, I'm going to show you what happens with the 45 reference angle. So in other words, all those spots that we just filled in or I filled in with blue, if we form this reference triangle here with the x-axis, we know this x value is this side right here, and we know the y value is this side, okay? We know the hypotenuse is 1 because this is the unit circle and that's my radius. And we know this is half of 90 degrees, so that makes this a 45-degree angle. That makes this a 45-degree angle. And here's what we know from last lesson, is that in special triangles, this and this side, the adjacent and the opposite side, which would be sine, let's call this, let's switch this up. Let's call this y. And the y value here, which is, I'm sorry, this is cosine and sine, that these values are the same length. And what length are they? Well, they are √2 times smaller than this. In other words, I want to go 1 divided by √2, which if I simplify that, I'm going to go √2 over 2. That's the value of x and y. And in this quadrant right here, that would be our cosine and sine, or x and y value, respectively. Now, the beauty of this is, so not only can I fill this in, but I can also go and fill this in right here. It's the same reference triangle. It has the same 45, 45, 90. It's just that the x value, because it's in quadrant 2, we studied, the cosine is negative. So it's negative √2 over 2. The sine value, or the y value, is positive. I'm going to do that same thing down here. The cosine is negative √2 over 2, and the sine value down in quadrant 3 is also negative √2 over 2. One more here, this 315-degree angle. The cosine value, or the x value, is positive, and the sine value is negative. And all of this we can tell because each one of those triangles forms this 45-45 reference triangle. And we know, and we've studied what the sines, SIG, ends of those angles in each of our quadrants. Okay, that gives us one other piece that we have, there's several other angles, though, we do need to fill in. And the other angles that I want to talk about are right here. So we have this angle, and this angle. So if I think of this piece right here, and I look at the slices of pies, I look at this, this, and this, it looks like that's broken up into 3 equal slices, and it is. The 3 slices are each equal, and so each needs to give me a sum of 90. That makes each of these 30. So this would be a 30-degree rotation. This would make this a 60-degree rotation. Well, let's just do this. Before I get to the 60, let's start off with all the 30s. So 30-degree rotation here. This one's 30 degrees off the axis, 30 from 180. So I'm going to subtract for that reference angle. That's 150. This angle right here is 30 degrees from the x-axis. So I'm going to add 30 to 180. That makes that 210. And I'm going to color code these. And then one more right here. This is 30 degrees from the x-axis. And so it's 30 degrees away from 360. So I subtract, that's 330 degrees. Okay, so what do we know about a 30-degree reference triangle? Well, let's check it out. If that's 30, that makes this 60. We know that this length here is 1. That's the radius. We know that this length here, if this is a 30-degree, I'm sorry, I got these in the wrong spot. My apologies to that. I am so sorry. This is a 30-degree rotation. So this is 30 and this is 60. And the way I knew that is I looked at these lengths. This length right here is the long leg, and this leg is the short leg. So I'd use what I learned from last lesson. The short leg, what's its relationship between the hypotenuse? Is it's half as big, or the short leg times 2 gives me the hypotenuse. That makes this short leg 1 divided by 2. And then this long leg over here, that makes this long leg root 3 times bigger. So when I'm computing this right here, this long leg is root 3 times 1/2, which is root 3 over 2. Okay, so this is my x value, root 3 over 2, and my y value is 1/2. And that's important to know, because what I can do now is I can go back to my unit circle and fill these in. Root 3 over 2, 1/2. This reference, the cosine, the x value is negative, root 3 over 2. The y value is positive, 1/2. Down here, the x value is negative, root 3 over 2. The y value is also negative, 1/2. And then over here, the x value is positive, and the y value is negative. Now, the beauty of this is this also helps me here. And let's use one more color here. So I'll use this color right here. If this is 30, this has to be 60 because this is 90. So these three pieces, 30, 60, 90. If that's 60, then I can fill in these other angles. This is a reference angle of 60, so that makes this 120, 60 away from 80. And then that makes this 240. Another reference angle here, 60 away from 360, makes this 300. And I do not have to go and build this triangle again. I want you to think about now this triangle is very similar to the brown one we just drew. Instead, this angle is 60 and this angle is 30. So this one becomes the long leg and this is short, but relationships are the same. So all I need to do is switch these two values. So my short leg is 1/2 and my long leg is root 3 over 2, which now you can see allows me to fill in the rest of my unit circle. Short leg or x value is 1/2 root 3 over 2. This one, the cosine or the x value is negative. Y value is positive. Down here, x value is negative. Y value is negative. Down here, x value is positive. Y value is negative. Whew, that is a lot. We can fill the rest of these radians in here. And I guess I'll let you either hit pause and fill them in. We can convert. We can count in terms of pi. This is 0. This is 1 pi. And this is 3 pi over 2. And then this is 4 pi over 2, which is pi over 2. We can do that same sort of logic. I'll let you do that. And that's going to be kind of for a future lesson. Just so we have it, I'm going to put them in here in purple. And again, you can fast forward this if you need to. What we're going to do now, you guys, is we're going to use this unit circle here. I'm sorry, this is 3 pi over 4. We're going to use this unit circle to answer some common rotation questions. And so you can think about these 30-degree marks. They break our things up into three equal slices for each quarter, which gives us 12 slices. So these are in terms of 12ths of 2 pi, and then they're just simplified. And then the other ones, this 45 breaks this up into 2 per quadrant, which is 8 total. So there's 8 of the 2 pi, and then that's just simplified. Okay, so what we're going to do is we're going to use that unit circle to answer some questions like this. Find the exact value of sine of 0. So you can go to your unit circle, go to 0 degrees. The sine is going to be the, it's going to be listed on there as the y coordinate. So write down the coordinates for 0 degrees. They're 1 and 0. The sine value is this coordinate, so our answer is 0. So these should be pretty quick. Find the exact value of cosine 90. Again, go to cosine 9 or go to 90 degrees, write down the coordinates. The cosine value is the x value. Done. Find the exact value of tangent 180. So go to 180 degrees. Use your unit circle we just created. Write down the coordinate pair. The tangent now, you might want to write yourself a little note, is the y over the x, right? And so if I position this, this is going to be the y value over the x, which is 0. Oh my gosh, it's always 0. Nope, not always. Tangent 270. Write down the coordinates. There's 0 and -1. Okay, the tangent again is the y over the x, so it's -1 over 0, which in this case is undefined. There is a button on Delta Math for you to put that there too also. These values, same idea. We have our unit circle, we've created it. Go to a 135-degree rotation, write down the coordinates here. I'm going to write down the coordinates. I'm looking at my unit circle here. You should look back at yours. And then the sine value is this y coordinate. So final answer, √2 over 2. These are quick ones here. Cosine 240. So go to 240 on the unit circle. That's this coordinate right here, coordinates of this point right here. The cosine is this coordinate. Final answer for this is -1/2. Tangent of 60. Tangent of 60. Go to 60 degrees. This has got to involve a little bit of arithmetic here because the tangent is the ratio of these two. It's the y over the x, which in this case right here, the y value is a fraction over the x value. When divided by fractions, don't cry. Invert and multiply. Basically, this is what we're saying here. You take this top one, you multiply it by the bottom one inverted. So this is 2 √3 over 2. Boom, boom. Final answer is √3. Find the exact value of tangent 315. Another one where we got to do a little arithmetic here. Tangent 315, I'm going to write down the coordinates of that point. What am I doing? 315. So √2 over 2, -√2 over 2. Ooh, I like this one. So y over x. I should probably be switching up my colors here. Y over x. Don't cry, invert, and multiply. And it's just, you're going to invert the bottom one. These are going to cross out. These are going to cross out. It does not equal 0, you guys. We're crossing out common multiples that are equal to 1. So really what I have is 1 times 1 over 1 times 1, and this negative sign makes this -1. Final.
So these last couple of problems are the same as the previous. The only difference in these problems is that instead of us giving degrees, we're now going to give them to you in radians. So your first step here is to go to this value on the unit circle, find the coordinates of that. So 2 pi over 3 is these coordinates from the unit circle we created. And then it says sine. Sine is the y value. So this is your answer for this problem, √3 over 2. Same idea for each of these. We'll just kind of follow the progression here. So cosine 5 pi over 4. First stop is to go to that spot on your unit circle, which is -√3 over 2 and 1/2. And it says, what is the cosine? That is saying, what is the x value? Final answer for that one is -√3 over 2. A little bit of work here now with tangents. With tangents, it's the y value over the x value. So what we need to do is we need to go to 5 pi over 6 on our unit circle. I'm going to write that down for you here. It's this x and y coordinate. And so we're going to put it in this order right here. So we're going to take the y over the x. We're going to keep, change, and flip. So we'll keep, we're going to change, and flip. So we keep the first fraction, this top one, we change it to multiplication, we flip the other one, and now we're going to simplify. The 2's crossed out, so I get -1 over root 3. We know we can't have a root 3 in the denominator, so we're going to multiply by this. This is called rationalizing the denominator. Final answer is -√3 over 3 for this one. The tangents involve a little bit more work. And the final problem here is this one. Again, we'll go to 3 pi over 2. That's these coordinates. And it wants the sign, which is the y value. Final answer here is -1. There you go. Good luck.